Now, for those of you who don't listen to me, these will not be the same questions on your homework. I'm going to change them. They are similar. Okay. So I'm going to change this one. I'm just going to make it 3 to the x equals 12. And I'm going to identify my pieces. And again, this is similar. This is how you do that one up there. The base is 3. It has an exponent of x, and the answer is 12. And Milbrath has just been pushing this whole log is bay. That's the deal. I just plug things in as I see them. So I have a log, her little base is a 3. I don't know why I typed a b. Her little base is a 3. Maybe. There we go. Her argument is 12. I identified it as 12 earlier. And according to the layout here, it equals x. It doesn't say solve, so you're just doing conversion. All right, here we have a natural log, so I'll do another one. We'll do natural log of x plus 4. We'll say it equals, I don't know, 7. Again, this is similar. It's to help. It's not correct answer for your question. Cason. Don't be a blind copier. Now, I know that ln has an understood base of e. So I'm going to go ahead and write that in. You should too. And I'm going to identify my pieces. This logarithm has a base of e. Kind of funny to use the e there. I think that gets some kids. It has an answer of x plus 4. And the resulting e is 7. And again, that comes from log is bay. Notice I'm just lining up. I don't know how many times I go over that, but that's what that comes from. So the logarithm is ready to become an exponential function. I identified the base as e. I'm going to raise it to the 7th power, and it literally equals x plus 4. And notice again, the instruction set says don't solve it. It just says convert it into an exponential function. Because that's what you're trying to learn here. This is the easy peasy Japanesey stuff. Write an equation modeling the following scenario. So we need a different one. This one says a small town's population triples every 30 years. How about we make a small town's population quadruples every 15 years? Because a small town is either going to do two things. It's going to die, it's going to stay stagnant, or it's going to grow very fast. And we're going to go with the optimistic approach that this one quadruples every 15 years. Now your layout here is going to be that the amount after time passes is the principal times 1 plus the rate of growth raised to some t. Now pay attention to that keyword every. That is a key word. That is going to make the exponent become t over 15. Now, what goes inside? If I quadruple, what do I grow by? I do not grow by 400%. All right, so let's take an example. If I weigh 200 pounds and I quadruple, I get my own show, I weigh, I don't know why I put a T there, I weigh 800 pounds. I increased by 300%. So R is 3. Now you're expecting a 4 because you know quadruple means 4. So you're about to see it show up. After some time passes, I am my principal, which we don't know. We just leave it as P. And then I have 1 plus 3. And then we know that 1 plus 3 is 4. Now, I don't know the principle here. You're just writing a scenario. But anyways, that's what happens after some time. There we go. So there's your similar one for that example. Keep it up. Heidi buys a new SUV for 33 grand that depreciates at an annual rate of 9.7%. Now, a new SUV ain't going to be 33 grand anymore. This was written pre-Rona. Pre-Rona. So Heidi buys a new SUV for $65,000. That depreciates at an annual, I'm going to leave that the same, rate of 12.3%. So here's my setup. My setup is that after some time passes, I am the principal times 1 minus r to the t. And we're using the word annual here. That's just an understood one. Annual means one. Kind of got in the way there, but there's a word annual. It's not every 3 months or whatever. Annual just means one. It's understood. So let's see here. I know that 12.3% is the decimal point 123. The principal for her scenario is 65,000. And if I do 1 minus 0.123, I will obviously clear it up. There's no need to change the exponent, but all I got to do is clean up what's in parentheses. Don't be the kid who leaves. Oh, I can't stand it. 1 minus 0.123. You're literally holding a cell phone with a calculator if you can't do it in your head. Use it. Just use it. 0.877 should be right. I did not do magic there. I didn't do anything special. The good Lord happened to give me a calculator. It's built in. But, you know, if you need to see that maybe I'm not right, there you go, 0.877. All right, that's where it came from. Moving forward, guess we need a similar here. We'll keep it a regular log. Let's make it 2x minus 3. Well, let's set it equal to 6. 7. No. This needs to be a small number. 3. Now, a logarithm has an understood base of 10. 10 is understood. Remember that whole idea? Understood base. So I'm going to identify my 3 pieces here. My base is 10. My answer is 2x minus 3, and that leaves e to be 3. And again, for the umpteenth time, log is vague. That's what this is about. Plug into that. I identified it by looking at that. Sorry, not plug into this. I take my logarithm, I make her an exponential. She is an exponential whose base is 10. Her exponent is this little 3 over here. And she has to equal 2x minus 3. A 10 cubed is 1,000, and it still equals 2x minus 3. I add 3, I get 1,003. It's equal to 2x. And I just divide by 2. And I, honest to God, don't care what 1,003 divided by 2 is. You want to push buttons, but that's the answer. All right, 9, we need a similar. Similar is going to be, let's just use function notation. H of x is e raised to, let's do a funky exponent, negative x minus 3. And let's change that to plus 8. And here's your 3 steps writing inverse. We swap x and y. We resolve for y. And we use correct notation. That's all we do. So we literally get the h out of this thing. That makes it, that's the swap. Our exponent will become negative y minus 3. And there's nothing happening to the 8. At this point in our life, we have to play a game called Isolate the Base. So I take away 8 from both sides. And now identify my 3 pieces. My base is that E because this E has an exponent, which I'm just going to go ahead and write down too. And that leaves this guy right over here to be my answer. And again, log is bay. Plain and simple. So I end up with a log whose base is E because, again, I identified it over here. The answer is x minus 8, or its argument, and it is equal to a negative y minus 3. And I'm almost done. This little 3 sitting pretty right there is going to get moved to the left. It's going to have a sign change. You'll notice I'm also rewriting that as the natural log of x minus 8, still equal to a negative y. And now I'm going to divide out the negativity. So I'd have a negative ln of x minus 8 minus a 3. And I introduced correct notation. This was h of x. It is now the inverse of h of x, written h to the negative first of x. Ta-da! All right, moving forward with my life. Another one of these inverses. Let's make ours a different base. Let's just do log base 7. The argument's going to be x minus 12, and we'll say minus 6. And we'll just leave it f of x. Why not? No need to change that. We're going to follow the same 3 steps I just did. They're not hard steps. The f of x becomes an x. It would be equal to log base 7 of y minus 12, and then take away a 6. I'm going to play the isolate the logarithm game. I'm going to add 6. The logarithm is successfully isolated. I'm going to identify my base. She's 7, because here's your base. I'm going to identify my answer. She is y minus 12, and I'm going to identify E as the stuff that's left over. And then, boys and girls, I'm going to convert into exponential notation. There's my base. It's 7. It has an exponent of x plus 6. And that has to equal the argument, or the answer, y minus 12. I am going to add 12 to both sides. And I'm going to use the correct notation here because I've technically isolated y. I've solved for y. And the correct notation is the inverse of f of x. Here's your similar. Finally, a solve, and we're supposed to leave our answer as an expression of E. So let's do our similar. Let's do 5 natural logs. We'll leave the x negative. We'll do plus 4 equal to, I should probably think this out here, or I just write some random number down, because it looks to me like I made this one not come out too bad. 29. And what we're going to do is we're going to play the isolate the base game. We're going to subtract 4 from both sides. We're going to divide by 5. By the way, what I just did there was I literally subtracted 4 because 29 minus 4 is 25. I am going to divide out the 5. And now I'm going to go back here and I'm going to put in that little itty bitty bitty understood base. And I'm going to identify my pieces. My base is the letter E. My answer is a negative x, which means that my exponent has to be 5. So E raised to the 5th power. Wow, has to equal negative x. So x is literally negative e to the 5th because we divide out the negativity that is in our lives. And we're done. I don't care what e to the 5th power is. So I'm moving forward with my life. Solve 7 to the x minus 4 equals 280. That's probably my problem. Anyways, round to the nearest 10,000th. I believe, and I'm not necessarily a smart man, but you have base of 7. She has an exponent of x minus 4, which means the answer has to be 280. Wonder if I should teach this with different letters, like maybe 280 is the result. That doesn't work for A for argument. Maybe I should spell a different word other than bay. I don't know. Anyways, now I've identified my pieces. I'm very bored at this point in time because I just keep doing the same thing. Log is bay. So I have a log whose base is 7, whose argument is 280, and it has to equal x minus 4. Now I'm going to do some stuff here. I'm just going to move that 4 on over. I'm going to make it positive. And even your calculators at home have a log key. This is the one on the PC. I'm just going to switch over to scientific mode. Oh, phooey. How do you handle? Oh, I actually did this one. So there you go. Forgot to do a similar one. Log base 7. Use change of base. You have these little formulas out here. It talks about log base B A. And I like this one. It's the natural log of A over the natural log of B. Or a lot of kids like log A over log B. They work. They're great. They're wonderful. They do the job. So I actually have to rewrite this. This would become ln of 280 sitting over the ln of 7. You can do logs if you want. Add your 4. And you know, the whole, I don't have a calculator, whatever. Oops, clear. Oh, this is a scientific one. I actually have to hit ln, I have to hit 280 ln minus 7 ln, add 4 equals. Notice how it's typing it. It's an old scientific edition. I forget what kind of form they're using here, but it kind of works a little bit backwards here. Anyways, it's about 7.68889. I forgot the whole equals x somewhere here, didn't I? That was 7.8889. Forgot to do a similar one. So this is the one you can blindly copy. You know, you can blindly copy this one. Moving forward, solve 4e to the x plus 4 equals 200. Express your answer in exact form, aka no rounding. Make sure I do a similar one here. Let's see, let's do 6e raised to the 2x. Why not? Make it 2x. Plus 6 equals 222. Now, what I'm going to do is I'm going to subtract 6. 6e to the 2x is equal to, hopefully I'm thinking right, 216. Then I'm going to divide by 6. I guess some of y'all need to see me actually do that because you're like, oh, where did that 36 came from? Where did that 36 come from? Well, again, the good Lord gave me a calculator. Let me put this back in standard here. I take 216 and divide it by 6, there's 36. Time to identify your bases and your answers and your exponents and all that good stuff. But your base is e, your exponent is 2x, and your answer is 36. Bay. So I end up with a log whose base is e. Her answer is 36, and she equals 2x. And log is ln. And I'm just going to divide by 2, and I'm going to be done. That's the natural log of 36 sitting pretty over 2, and that's my answer. You do the same thing, exactness. How much would you need to deposit an account that pays 7.3% compounded quarterly so that you have $40,000 after 25 years? My hands are starting to hurt, so I'm going to switch over to writing. The guys may not realize it, but I have been using technology my whole life, and it has really gotten to my hands. So let's make this 60,000. Let's do a really, really low rate. Let's just do like 5.9%. We're going to leave that the same. And let's say 15 years. So we're using the compound interest formula. After some time passes, we have the principal times 1 plus r over n to the nt. Quarterly tells me that n is 4 because there are 4 quarters in a year. Now, I want to know how much I need to deposit. I want P. What I want. This is after time passes. Let's do brown. I never used brown. The goal is to get to 60,000. It must equal the principal, which is unknown. 1 plus r. I used 5.9, which is going to be 0.059. N is 4. I made my time 15 years. I also made a mistake. I was supposed to put a 4 there. So n times time is 15. And if you look at this big piece right here, that is literally, go to a calculator and push some buttons. I'm not even pulling up my TI-84. I don't need to. I don't think I do. Does this thing have parentheses? Well, I guess I can do it this way. 1 plus 0.059 over. Oh, you got to be careful on this one, don't you? Ooh. Yeah, this one stinks. This one you have to do 0.059 divided by 4. And then add 1. There we go. Now, 4 times 15 is 60. So I'm going to rooftop it to the 60th power. Oh, this thing won't do it, will it? Well, bummer. Okay, let me switch over to scientific. 1 plus 0.059 divided by 4, close parentheses. Where's the little exponential key on the scientific mode? There she is. Raised to the, if you don't know what 4 times 15 is, 4 times 15, close parentheses. I got that funky looking number. I'm going to keep it out to here, and that 3 is going to become a 4. 2.4074. 2.4074. That is attached to the P. So what I'm going to do is I'm going to divide it out. So I take my 60,000 divided by, the only reason I'm actually using this calculator is so I don't have to listen to the crap about I don't have a calculator. There you go. $24,923.15. 24923. 24 923 and a penny. Sorry, I don't know why I said a penny. 15 cents. That's what you got to invest. Now, notice I'm using that old calculator. It's harder to use, slower to use. Graphing. All right, so let me do something similar. I'm going to do 4 times 2 raised to the x plus 1. Let's make it 2. And then minus 3. And what I'm going to do is I'm going to strip this, actually, I'm going to strip this down to a much simpler form, 4 times 2 to the x. And I know that 4 times 2 to the x must contain the point 0a and 1 comma ab. Has to contain it. And by the way, I'm doing this because that's literally ab to the x. So I must contain 0, 4, because a is 4, and 1, 4 times 2, 8. Now I'm going to go back over here and I'm going to look at the transformations. I got that right there, which is x plus 2. There is a left 2 move. So it becomes negative 2, 4, and 1 minus 2 is negative 1, 8. There is also this other transformation, minus 3, which is a down 3 translation. So if I take away 3 from 4, I get 1. And if I take away 3 from 8, I get 5. And that's my final pairing. So I'm good to start drawing. The only transformation I'm actually going to show on my grid is this whole left 2. Sorry, on this is exponential. I'm going to show the minus 3. So I've got negative 2, 1, which is right there. Negative 1, 5, which is actually something seems incredibly wrong here. I have to contain 0a, so 0, 4, and 1, 8, because I'm growing. Oh, I can't plot points. I have dyslexia, don't I? Negative 2, 1 is right there. I don't know what was wrong with me. Anyways, I know what growth looks like. I know this is growth. There's a 2 there. And it'll look like this. I'm going to kind of flat line near that asymptote. And that's what I look like. So I want my domain. It is negative infinity to positive infinity. Runs left forever, runs right forever. All exponentials are. My range is negative 3 to infinity. End behavior. As x moves left, which means we go to negative infinity, the y value gets close to negative 3. As x moves right, which means as x goes to positive infinity, the y value rises. And there we go. One more and I'm done with this. All right, so let's do a similiar. G of x is log base 4, because why not? Let's do x plus 7, because why not? And let's say minus 3. Now I'm going to do the same kind of strategy. I'm going to strip this down to log base 4 of x. Now I know things I'm supposed to know. I know that it must contain 0, 1, and base 1. So this thing has a base of 4. It has to contain 0, 1, and 4, 1, because that's what logarithms do. So I'm going to start kicking in these transformations. You got x plus 7, which is not a right 7 translation. It's a left 7 move. To move left 7, I would take away 7 from x. So 0 minus 7 is negative 7. And I'd take away 7 from 4, which is negative 3. Then I also see this minus 3 at the end. I have a down 3 move. So if I take away 3 from 1, I'm at negative 2. And if I take away... Dyslexia hit me, man. Oh, I hate it when that happens. And I just went with it too, like an idiot. Anyways, left 7. 1 minus 7 is negative 6. No effect on y. That one's right. If I drop 3, I'm at negative 9. Sorry, I'm still at negative 6. And 0 minus 3 is negative 3. Glad I caught that. And then I have 1 minus 3, which is negative 2. This is more what I'm expecting, because logarithms look like the letter R, and they grow as they move right, generally speaking. So there's my ordered pairs, and I can start graphing. I had to go left 7, didn't I? Let's move that over a little bit. The left 7 I'm going to draw in, because it's important, because logarithms have vertical asymptotes. I didn't mention that, did I? Let me go back to this one. Horizontal asymptote is at y equals negative 3. I'm going to change the instruction set up here. And asymptotes. All right, so we go left 7. Switch over to my pencil versus my trackpad. 1, 2, 3, 4, 5, 6, 7. That's the important one. It's important because it happens to be the vertical asymptote. It's at x equals negative 7. You don't have to draw in the downs on logarithms, you can, but it doesn't really do it. There's some benefit in it, depending on how this is taught. If I was teaching pure translations, it would make sense. I'm not. Anyways, I need negative 6, negative 3, which is going to be right here. And I need negative 3, negative 2, which is going to be right there. And then I'm going to draw my R. It's a logarithm, which I don't have anywhere mentioned here, but logs look like an R. It's literally what they look like. Now, I don't know what exactly the behavior towards the end, but I know the behavior towards the asymptote. And that's what she looks like. So let's do all the things they want. The domain is from negative 7 to the right. Again, learn how to read this, not memorize it. The range is negative infinity to positive infinity. There is a vertical asymptote. It's at x equals negative 7. And the end behavior, which I hope you understand, as x approaches negative 7, because that's as far as you can go, the y value approaches negative infinity because it is falling. And as x approaches the right, which means it's moving to the right forever because it can, the y value increases forever to infinity. And that, boys and girls, should be the end of the similar questions for your practice sheet. I'm sure there's a couple of you out there who blindly copy, who absolutely are ticked off at me because I didn't do the same questions. Ha ha, ha ha, ha ha. Figure it out.